So the next slide, sir.
This?
Yeah, sir. You were in the third one, sir.
Okay, okay, fine.
Hygrometers.
Hygrometer. Okay,
Yes, sir.
so we just run through it again. Now, hygrometer is an instrument used for measuring the moisture content in the
Sir,
atmosphere. Yes.
sir, me and Keshavaya are in the same link, sir, because there's connectivity problem. We've connected from one mobile.
Okay, when I call the attendance, you tell me that.
Okay,
Okay.
sir. Okay, sir.
Yeah.
Okay, sir.
Yeah.
Thank you, sir.
Okay. So the hygrometer is an instrument for measuring the moisture content in the atmosphere. That means for measuring the humidity. Okay. So they use sensors which react to varying levels of humidity by causing a physical change in a material which changes its electrical properties. The material's electrical property is calibrated to humidity. So I said we have got some 9 energy audit instruments. Then we have the light meter. This measures the illumination or light level in units of foot candles or in lumens. The light emitted by the area of interest passes through a light sensitive layer of cells contained in the meter. This light is converted to an electrical signal proportional to the light's intensity. So this is also one of the instruments used for energy energy audit. Then we have the multimeter. So multimeter, commonly most of you would have seen this gadget. This is for measuring the all electrical units like voltage in terms of volt, current in terms of amperes, and resistance in terms of ohms. So multimeters, we have now. Multimeter is a just, it looks like a kind of a mobile only, except it has two leads coming out with the pointers, with the stainless steel pointers, and if you touch the two pointers together, you will find the needle moving. Okay, now there are different settings for, if you want to check the resistance, you want to check the current, or you want to check the potential difference, that is the voltage. You can do accordingly any setting, and these are for checking the continuity of something. Something is not working, you can make out where the issue is, whether the issue is that there's no current itself flowing into that, or there is an issue with the plug point or the wire or the the device itself that you are checking. So the calibration will be from, for current it is from 0 to 300 amps, for voltage it is from 0 to 600 volts, and from for the resistance it is from 0 to 1000 ohms. So these are the ranges. So anything more or less than this, you may have to use some other instrument. Then we have the pH meter. So the pH meter, as the pH itself, you know what is the pH value of any of water, right? Whether the water is acidic or alkaline. If the pH level is 7, then it is a very neutral water, neutral solution, pH 7. Between above 7 to 14 is strongly acidic, and from 0 to 7 is strongly alkaline. Okay, so 0 is the very strong alkaline, 6 will be mild alkaline, 7 is neutral, and 8 will be acidic, lightly acidic, and goes to 14 where it is strongly acidic. So these things are used also for energy audit, where you need to find out the pH of something, because unless the pH is of something that whatever will that is using certain energy, whatever energy it is using, they'll give a pH for that. So if the pH is not matching that, then maybe they think whatever device it is not doing its job, so it is wasting energy. So they can find out, then they will say, yeah, because your solution is having this pH, that is why your thing is consuming more energy. So these are all ways of auditing the energy. Now coming to the power factor meter. So this, what is this power factor? We discussed this in our previous last year in the what is it, sem 2, yeah, sem 2, under some subject which I was taking for you. So this is used to measure the power factor of electrical equipment, particularly three-phase motors. So you may be aware that there are two types of motors. I mean, the consumption, the power that is used, it's either single phase or three-phase motors. So three-phase motors are very efficient and can be used only where three-phase power is available, and used mostly in industries. So the power factor is a measurement of the electrical current in a wire which is doing useful work compared to the total current, electrical current in the wire. So how to explain what is this power factor? When you have current in a wire, okay, the current which is doing useful work is the power factor, okay, compared to the total current in the wire. That means let the total current be 100, okay, 75 is doing useful work, for we are using the current for something, right? So that useful work. There is 25 which is not doing useful work because of the resistance of the wire, right? So that is the power factor, that is the useful against the total. Now we have the next instrument, which is the non-contact infrared thermometer. So as the names, from the name you can make out that the thermometer is not to be in contact, right? So these are, how do they work? They work on electromagnetic radiation emitted by solids or fluids. The radiation is characteristic of the temperature. The heart of the infrared thermometer is the detecting surface which absorbs infrared energy and converts it to an electrical voltage or current. Okay, so it shows either the voltage or the current, and we are able to find out from this whatever we are trying to come to know. So these infrared thermometers nowadays are everywhere, you can see them, like they aim it at your forehead to find out the temperature in your body. It all, I think most of the establishments are having this to allow you entry inside because of the pandemic. Then the last one I have here on my list is the non-contact tachometer. So the tachometer is to measure the revolution of something that rotates. Okay. Now we have a motor. How many revolutions it does per minute? Anything that rotates. So to find out that, now suppose, because now for example in some machine the revolutions should work, say maybe 100 revolution it has to do in a minute. Okay, so unless it does 100 revolutions for the particular power it is consuming, say 50 or 100 watts is consuming per hour, it has to do, let's say 100 revolutions. And when you do an audit check, you're finding that it is doing only 60 revolutions for the same 100 watts of power, then definitely it is having an issue. So we can able to find out that this something has to be done, okay, to change that. It is wasting power, wasting energy. So in this, non-contact tachometer employs a variable frequency flashing light which makes the rotating component appear to stand still when the frequencies match. Okay, so how the reading is done is there is a flashing light, okay, and at one particular point it will remain still. So then you know that the frequencies are matching. So they will be having some frequency given or the revolution. So when that correctly matches together, the flashing will stop. So then they will know what is the how many revolutions or what it is doing per minute. So these are some of the instruments. Of course, there are, I think, few more are there. So we may not look into all the aspects. Only thing what you need to remember is some of these names and what purposes they are used and how they contribute to energy auditing. I think I lost some five minutes maybe. So now we look into energy conservation. So we must have heard about energy conservation. Everybody talks about energy conservation or energy efficiency. So all these things. So what is actually this energy conservation? Energy conservation is any behavior that results in the use of less energy. So whatever behavior you do to use less energy is called conservation. For example, when you leave a room, you turn off the lights, say night time, you're using it. So once you leave the room, you turn off the lights. So this is responsibility which contributes to conservation. Or recycling things. You might have heard of the 3 R's, huh? Reduce, recycle, so reuse. So these responsibilities of us, will help in conserving energy. So on the other hand, what is energy efficiency? This is using technology that requires less energy to perform the same function. For example, we have a incandescent bulb which is using some amount of power and giving some amount of brightness to the room. Now, when we use alternate luminaires like the LED or the CFL bulb, the compact fluorescent light, there you are getting the same amount of light, but the energy consumed is less. So this only is energy efficiency. Unlike energy conservation, where you get concerned about using whether it is energy efficient equipment or conventional equipment, you're concerned, you turn it off, you try to use it minimum. So how are all these things done? Like, for example, we have an air conditioner. Okay, so once you find it cool, you want to turn it off. You don't want to keep it running, because from the consideration of you're using energy continuously, and also you're feeling cold. So energy conservation is not about making limited resources last as long as they can. Okay, that would mean that you are doing nothing more than prolong a crisis until you finally run out of energy resources altogether. Conservation is the process of reducing demand on a limited supply and enabling that supply to begin to rebuild itself. So already we have talked about what is supply and demand. Okay, so we have to reduce the demand on a limited supply. Many times the best way of doing this is to replace the energy used with an alternate source, like wind energy, solar energy, and so on. So people use energy for transportation, cooking, heating, cooling rooms, manufacturing, lighting, entertainment, and many other uses. The choices people make about how they use energy, turning machines off. See, this is conservation. Turning machines off when they are not using them, or choosing to buy fuel efficient vehicles and energy efficient appliances affects the environment and people's lives. So without energy conservation, the world will deplete its natural resources. And deplete means get it will use it up. While some people don't see that as an issue because it will take many decades to happen, and they foresee that by the time the natural resources is gone, there will be an alternative. So the irresponsible people think that way. The depletion also comes at the cost of creating an enormous destructive waste product. So not only we are using up, when we use the product, we are giving out waste product, carbon dioxide, that impacts the rest of life. So the goal with energy conservation techniques is to reduce the demand, protect and replenish supplies, develop and use alternate energy sources, and to clean up the damage